Good morning, ladies and gentlemen. I'm sorry I'm getting a little bit of a later start rather. You should have your notes that you took the other day in front of you, 6.2 characteristics of exponentials. Just as a quick review, our exponential equations are going to be in this form, where your A value is going to be your number in front, your B value is going to be your base, or your growth or decay factor. We'll talk about when it's a fraction or when it's a whole number, meaning growth or decay. And then your C value is going to represent your asymptote, or the boundary that affected the range that you saw in your exercises the past couple of days. Okay, so now on the left side of your notes, if you have your journal, or on the back side of your notes, I want you to divide your paper into 4, and we're going to do 4 examples together. So this first example is going to be f of x equals 1 times 3 to the x plus 0. Now you're going to be completing a Google form, a worksheet essentially, where you're going to have to do a couple of things. What does A equal? What does B equal? What does C equal? What is the y-intercept? Domain? Range? Asymptote? Increasing or decreasing? And then we'll draw the little sketch. Okay, so what does my A equal? If I go back to my notes, my A is my number in front. Sometimes you'll have a decimal, sometimes you'll have a parenthesis set rather, sometimes you'll have the dot, that means multiply. So my A value is 1. My B value is my growth or decay factor, which is the number that belongs with the exponent. So my B is 3 in this example. And my C is my number out front that I'm adding to. And so this case it's going to be 0. To find my y-intercept, I'm going to have to graph it. I suggest you guys using Desmos. You're welcome to use your calculators, but I would suggest using Desmos, and I'm going to include that link as well. So 1, to get the times button, you push shift and the number 8, and that will give you the dot. 3 to the x is going to be shift and 6, because 6 has the caret above it, and then your x is going to go in the top, and to get the plus 0, you arrow over on your keyboard to the right, and that makes it type normally, and then plus 0. So here's my graph. And Desmos makes this really easy because it shows me very simply where my y-intercept is. So my y-intercept is at 0, 1. So I'm going to go back to my y-intercept, and it's 0, 1. And as a little trick, going back to your notes, your y-intercept is your A value when your C value is 0. And so because in this example I have a 0 on the back end here and my C is 0, my y-intercept is going to be whatever my number is out front here. And I do want you guys to report it as x, y as a point. My domain, and you guys should have been practicing this for a while, is going to be all real numbers. We're not going to be doing any real world examples for a while. And my range value is going to be some sort of y. Now let's go back to my example. So here's my asymptote at y equals 0 rather. And all of my range values are going to be greater than that. They're going to go up from y is greater than 0. So my range is going to be y is greater than 0. My asymptote is y equals 0. And that asymptote value is going to come from my C value. And that's on your notes on the left side. That's the boundary the graph cannot cross. Now looking back on our graph, is this curve increasing or decreasing? Increasing, or growth, is going to be going up from left to right. And so in this case, I am increasing, or this is growth. And going back to your notes, if your B is greater than 1 or a whole number, that represents growth. And because my B value is a whole number, 3, that's also going to cause the graph to increase. And so a quick sketch of my graph goes right there. Okay, now let's try number 2. F of x equals 1 times 1/2 to the x plus 0. A equals, B equals, C equals. My A is 1. My B, or my growth or decay factor, is 1/2. This is a fraction, so now this is going to be the opposite of the example 1 that we did. And my C is 0 again. My y-intercept, you either can find this by using your graph, or because my C value is 0, my y-intercept is whatever my A value is. And it's 0, 1. Again, you can check this in the graph. We're going to double check this in a second. My domain, you can check this using your graph, but I know that it's all real numbers. It's not a word problem. My range, we're going to have to check using the graph now. So I'm going to go to my graph. 1 times, now you can use this with parentheses, so you can always start over. 1 y equals 1, and I'm trying this now in parentheses. So 1/2 is 1 dash 2. Do you see how it now makes it as a fraction? And I'm going to tab over, make it type normally again, and then put the parentheses. You might have to experiment with that for a little bit. I want you guys to try that out. And then to the x plus 0. Excellent. So now I can check my y-intercept is at 0, 1. That's what we saw already. And my range is going to be all of my y values greater than 0. My asymptote is at 0 again. And so now I'll go back to my notes. My range is going to be y values are greater than 0. Again, it's not going to be equal to 0 because it's never going to cross that 0 boundary. My asymptote is my C value, or at y equals 0. That's that boundary, that dotted line that you guys saw in IXL that the graph can't cross. This graph is decreasing. It's decay. If I look back on my graph, it's decreasing from left to right. It's getting smaller. So this is a graph of decay. And then I'm going to draw a little sketch. My decay. Excellent. 2 more here. Example number 3 is a medium problem. Excuse me, guys. A equals, in this case, it's 3. My B value is 5. This is a whole number, so that means this is going to be an example of growth. And my C value is 0. My y-intercept, I'm going to have to use by finding the graph, because I can't say my y-intercept is my A value. My y-intercept is my A value only. Oops, actually this does work. My y-intercept is my A value when C equals 0. So my y-intercept is going to be at 0, 3. I was getting too excited, guys. I'm sorry. My domain is going to be all real numbers. My range, I'm going to have to get after I graph it. So now I'm going to go to my graph. Y equals 3, parentheses 5, to the x. And I can always check my y-intercept, yep, at 0, 3. My range values are going to be everything greater than 0 again. Your range is oftentimes going to be y is greater than 0. My asymptote is my C value, so it's at y equals 0. And because of my B value being a whole number, and even when I take a look at the graph, this is an increasing graph or a growth graph. And then I'm going to draw a little sketch. Last one. This one's a little bit spicy. My A equals, my B equals, and my C equals. Don't worry, they can't see me dressed like this. No. All right, my A value is my number in front, which is 4. My B value is 0.3. This is a decimal value or a fractional value, so that means this is going to be a decay graph. And my C is 1. Okay, so now my C value is 1. This is going to be something different than the 3 previous examples we've done. So my y-intercept can't be my A value because my C value doesn't equal 0. So now I'm going to go to my Desmos, and I'm going to put 4, parentheses 0.3, to the x plus 1. Okay. My y-intercept is at 0, 5. Now a little trick is that my y-intercept is my A value plus my C value. That's just a little trick, and we're going to be working on a lot more of these spicy problems later. Okay, my domain is all real numbers. My range is going to depend on my asymptote. So let's look back on our graph. My asymptote is at 1. Y equals 1. So that means that my range values are going to be everything greater than 1. My asymptote is my C value, so that's y equals 1. This graph, because of the decimal value for my B value and because of looking at the graph, this is decreasing from left to right. It's decay. Then my sketch, it's a little bit higher because of my asymptote at y equals 1. Now I want you guys to try out the Google form worksheet, and please let me know if you guys have any questions.